I mean, I didn't call to remind just because I should do that. Are we on the air?
We are.
We are on the air. Well, this is Mary Lou and Melanie down at the Box of Books Library, and it must be Friday.
It's a Friday.
Friday at 11:30 Eastern Standard Time, right? One of these times we'll have to talk about time.
Right.
I'm writing an article about it lately. All righty. Clouds. Basically, we're going to talk about those lovely puffy things. Well, sometimes they're lovely and puffy. The clouds that are up there in the sky. And I thought what we're going to have to do is first I'm going to talk about how they are made. You know, they just don't magically appear up there. There's all sorts of scientific reasons. And then what am I going to do? Then we're going to talk about what's called the family of clouds. Can you hold that book up so they can see? This is, I think I gave you this book a few years ago. Right. It's a great book if you just want lots of pictures. Maybe there's one chapter in the beginning on the science of it, but it's very simply stated. But most of it's just beautiful pictures that this fellow took from all, well, I think most of them are from the Midwest because that's where he lived. But anyway, any kind of cloud or combination thereof that you can imagine will be in this book. And then after the families, I guess that was it. So we're going to try and get done within the hour. Melanie's got a hook lying on the floor and she's going to yank me off the stage when we get to 12:30. Okay, just a bit of review. Okay, Melanie.
Oh, gosh.
Question time. I think you know this one.
Okay.
Our Earth is unusual compared to all the other planets in our solar system. What percentage, roughly, is it water? Oceans.
A lot.
A lot.
Like close to 80%.
Okay, close to 80. That's better than the other way. Yeah, about 70% is ocean. And as a matter of fact, you can take a picture of the Earth from somewhere over the Pacific, kind of zeroing in on Hawaii. And basically all you see is water. Off in the upper right-hand edge and down around the curve is the very edge of North and South America. And way over here might be, I don't know if it was part of Australia or maybe a little bit of Japan, but it's all water. So we who are land creatures don't tend to think of that. Right. But that's true. And then a few weeks ago, I wanted to say that almost all of our weather is because of the water vapor. Water, and it's the gas stage that's mixed into our atmosphere. It's that water vapor that causes the weather mostly. And then I made the wonderful analogy, and I'm going to make it even simpler this time. If you start with $1,000 bill, I don't even know if they're legal anymore, but you used to be able to get $1,000 bill and then divide it down into pennies. The amount of vapor in the air compared to all the rest of the air is like 1 penny to that $1,000. So it's not much, is it? Right. But amazing what it can do. Right. Which is also, I think, a cautionary tale in general in science. Sometimes somebody says as they throw that trash into the ocean, this ocean is so big, what is my little bag of trash going to mean? Well, with some things, a teeny tiny bit can really screw up the works. So that's something we are learning in this decade, in this age. And the weather then, once again, a reminder, 3 things basically: the temperature, the humidity, and the air pressure. All those 3 things are intertwined. Some go up, some go down. Some get denser, some get less dense. And with all that changing of the temperature, the humidity, and the air pressure is what produces the weather. Unstable air, a mixing of these things. And then we really didn't get into the weeds on the science, but that's okay. Sometimes at this level, you don't need to know all the details. Now, this is like This is like the meteorology class I taught to 8th graders
Right.
many, many years ago. We don't need to go to the college level 101, 102. You know, if you want to do that, go to the library and get books out.
Mhm.
Okay. So in general, as your temperature goes up in the air, the humidity will go down. And I mentioned anybody who gardens in the summertime nowadays, when we have these hot, humid summers that we didn't used to
Mhm.
have. So working out in the garden can be unpleasant for 3 months out of the year
Mhm.
now, from June, July, August. So I've discovered that if I check the temperature and the humidity early in the morning, I'm thinking, I'll go out at 7 o'clock when it's not as hot.
Mhm.
It's only 70 degrees. But the humidity might be 85%. So do I really want to go out in a 70-degree Fahrenheit when the humidity is that high? What if I wait till 2 o'clock in the afternoon? Well, it's going to be hotter
Mhm.
unless a front comes through. It might even be 80, but your humidity has gone down,
Mhm.
maybe to 70 or even 65.
Mhm.
So anybody that has been outdoors working in this kind of weather realizes it's like they going to Arizona.
Mhm.
It's the dry heat. You don't feel it as much.
Mhm.
And that's really true out there,
Mhm.
where the humidity might be 40%
Mhm.
and the temperature 90, but you're much more comfortable because you're sweating.
Right.
Yeah. Okay. So up and down, in balance, sometimes out of balance. The other thing we learned was that a volume of air at a certain temperature can only hold so much vapor, gas, water gas. And when it reaches full capacity, as much as it can hold, we call that 100%.
Mhm.
And that's why the weather report usually gives humidity in percentage. They say the humidity today will be 50% or 90% or whatever. That percent is how much compared to the total it could hold.
Mhm.
Once it gets to that 100%, what happens?
Precipitation.
Precipitation. We call it the dew point. The more humid the air, the lower the dew point. The drier the air, the hotter you have to get before
Mhm.
it will condense out as either water vapor, or what if it's below 32?
Snow.
So, okay. Hey, it's in the homework. All righty. So when that dew point is reached, the vapor changes state. It goes from a liquid, no, it goes from a gas in the
Mhm.
air, invisible, like it's here now around us.
Mhm.
We just can't see it. It either comes out as little tiny droplets or tiny ice crystals.
Mm.
And since that column of air, as it rises, cools, it reaches somewhere at the dew point, and that's when your clouds will start to form.
Mm.
And depending on how high it is and what the temperature is at that point, you'll either have the beginning of tiny little raindrops or little ice crystals. Now, the other thing you need up there, we all want pure air, right?
Mhm.
If you could wave a magic wand, Melanie, and get rid of all the pollution,
Mhm.
all the salt, dust, if you would you do that?
No, because then we wouldn't have weather, right?
Well, we wouldn't have any precipitation
Right.
because for some weird physical, you have to study physics 101, but we're not going to do that. We're just going to tell you. You need teeny tiny microscopic particles up there. It could be dust. It could be that stuff that comes out of your tailpipe on your car. It could be salt crystals. What else? A few other things. But anyway, and they're up there in smaller or larger amounts. You drive over the mountains going south into the LA basin in California, and you can't see the LA basin because there is this brownish smog layer. And if your windows are open, as soon as you hit it, you can feel it in your lungs. So, since the air around us is not pure, it has these little tiny particles that the vapor can condense on.
Mhm,
And so we wind up with the beginnings of clouds.
mhm. So do we have more precipitation now than we did, prior to the Industrial Revolution and?
I'm heating up a pot of water on my wood stove
Mhm,
because my house is so dry. Um, if the wood stove is hotter, how fast does it boil off?
very fast.
Faster.
Yeah.
So yes, as the temperature of the ocean,
Mhm,
that's 70% of the Earth's surface, is warming, and it is warming by 1 or 2 degrees in the last 70 years or so. That means more water is evaporating from the surface.
mhm.
So our air is becoming more humid in
Okay.
general, not everywhere. You know, we
Sure.
still have our deserts, but in general.
Mhm,
And more humidity usually means more precipitation
mhm.
of one sort or another.
Yes.
All right. Good question. And where are we? All righty. Now that we've done that, whatever that was, basic review or something, let's talk about how clouds form. And why don't we, can you find that beautiful picture of the cumulus, the fair weather summer clouds?
Um, is it this one?
Um,
That's cumulonimbus.
Nimbus. Do we have just a plain old fair weather clouds? I thought I saw it
did.
there.
Oh,
Yeah, there we go. That one. All right. Fortunately, Melanie's the head of the library and she's the only one here today, so we're hoping no patrons come in this hour. Because if they do, then she
Without it.
abandons this to me and I don't know what button to press. All right, it's summertime. Let's say late middle of May, June, July, August. And the skies are clear at
Mhm.
dawn, pretty much. And there's usually no wind in the morning either on those days. And so you get up to a nice sunny day. And by 10 o'clock in the morning, you begin to see, well, there's actually 2 kinds of clouds here.
Mhm.
We're going to focus on those puffy white ones. We're going to ignore those wispy ones for now. They're higher up in the atmosphere and are made of ice and are called cirrus clouds. These puffy ones are called fair weather clouds or cumulus clouds. And they usually stay mostly white and round, and they don't usually fill up the whole sky. They float around all day long, coming and going. And have you ever gone sailing on a sailboat, Melanie? No. Well, when I was in college, I had a boyfriend who had access to a sailfish sailboat. And I was working here in Alfred for the
Mhm.
summer, and we spent our weekends down at Keuka Lake
Hmm.
sailing this boat around. And I quickly learned, he already knew,
Mhm.
you can get over to Keuka Lake and get your boat out in the water around
Mhm.
10 or 11, and you can sail around for several hours, picnic on an island or whatever. But by 5 o'clock, you better head back for the
Hmm.
dock. Because what tends to happen on a day like this as the late afternoon and early evening progresses to the wind and the clouds?
There's more of them and it's windier. No.
No, you're going to get stuck out in the middle of Keuka Lake with the paddle. Because
This is why I don't sail.
that's how
Nobody wants
Yeah.
me to sail.
Okay. Now, I want everybody to notice this. Well, of course, it's the wrong time of year. You're going to have to wait till summertime. But almost always, unless a front is coming through, if it's a stable air mass over
Mhm.
your area, as the sun begins to fade in its intensity, these puffy fair weather clouds begin to disappear and the wind begins to die, and you'll be stuck out on the lake having to paddle back to the dock if you don't take advantage of the last dying wind.
Okay.
Okay.
And why does that happen?
Why does that happen? Well, let's say why it happens in the beginning. So in the morning, see if I can remember how this works. Once again, this is 7th, 8th grade basic
Mhm.
math. Do you remember the 3 ways heat's conducted?
Oh gosh.
What's over the sun? How does that heat reach you?
No.
Radiation,
Radiation.
right? The sun and the magic of the sun, it passes through all that
Sure.
empty space. How does it get here? By radiation. And we're not going to explain that. We're just going to give it a label. Sit in front of your wood stove, same thing, radiation. So early in the morning, as the sun rises, it takes a
Mhm.
little while to gain height, and you begin to feel the heat of the
Mhm.
sun on a summer day. It directly warms the ground or the
Mhm.
lake or whatever, the surface, by radiation.
Mhm.
Then the second, if you touch a pot handle that's not insulated, just a metal, what happens?
You get burned.
You get burned. Conduction.
Mhm.
So the heat that the ground absorbed via radiation is transferred to the air just above it, not very high, by conduction,
Okay.
contact. Then, because air is a fluid like
Mhm.
water, we set up
Convection.
convection currents where as the heat, let me think now, as the heat increases in that column of air, then the molecules are moving
Mhm.
faster. They're expanding.
Mhm.
As they expand, it's less dense. Less dense means it rises.
Mhm.
Doo-doo-doo-doo. And then as it rises, something else happens. Why do we all go to the mountains in the summertime? Well, that's what we used to do before air conditioning.
Oh, yeah, it's cooler.
It's cooler higher up. So part of it is the further from the surface of the earth
Mhm.
you get, in thousands of feet, the cooler it gets. An good example of this is I live at 2,240 feet above sea level on the top of Jericho Hill.
Mhm.
Cornell and Wellsville are about 1,000 feet lower.
Mm.
And if it on any given time, I am normally 6 degrees cooler than
Mhm.
down in the valleys,
Mhm.
which also means spring comes about a week to 10 days earlier in the Maple City, Hornell.
Mhm.
The maple trees leaf out about a week to 10 days before they do on the top of my hill. There's another reason for that, and we'll get to it in a bit. Back to our convection currents. The column of warm air is rising and cooling and expanding, getting less dense. It keeps going. As the temperature drops, what does it finally hit? That magical
Dew point.
dew point. At which point the clouds begin to form.
Mm.
So the more humid the day, the lower the clouds will start forming, right? Because you don't have to drop that
Right.
much. On a drier day, they have to go higher up before they get cool enough. So now there's a special word for that. Melanie's disappearing on me, but that's okay. Scientists has measured the rate of cooling as the air column goes up, and it's called adiabatic, Adiabatic, and it's just about 5.5 degrees Fahrenheit for every 1,000 feet, which is why I am about 6 degrees cooler than Wellsville or Hornell, because I'm 1,000 feet higher. So this adiabatic cooling, it happens for two reasons. Hi, we have a librarian patron here. You are now going to be in the cloud forever because you walked in front of us. Okay. Are you here for the talk?
She is.
Talk. Why don't you scoot over there where I can see you? And I'm not wearing my mask, so I like to keep a little distance. Okay. All righty. Okay. So that cooling is really for two reasons. Partly just because you're going higher up into the sky, further from the earth, and it's cooler up there. But the adiabatic cooling is also because of what we call latent heat.
Mm.
In this case, loss. And that goes back to what we talked about, I don't know, a week or two ago or so, that when a substance like water changes from an ice to a liquid to a gas, depending on which way you're going, it takes heat to do it.
Mm.
And when you reverse the process, that heat is given back up. So when the water gas condenses to liquid, it gives up heat.
Mm.
And when it goes all the way to ice, it gives up more heat,
Mm-hmm.
which is why the water freezes.
Mm-hmm.
Okay, so that's something to kind of have to think about. But we all know how we can get burnt by a steam. That's the latent heat burning us.
Mhm.
Not just the hot water, that's 212,
Mhm.
because the steam can give off a lot more heat than 212.
Mhm.
So anyway, and that's also, I don't know if we'll go into it maybe when we talk about precipitation, but the fact that water, when it goes to ice, does something very, very, very strange in the universe.
Hmm.
It doesn't keep contracting as it gets colder like everything else does. It reaches about 39 degrees Fahrenheit and it starts to expand,
Hmm.
which means our oceans, our lakes, the ice then floats to the top.
Mm.
If it didn't do that, if it was like everything else that kept
Mhm.
shrinking as it got colder, it would settle to the bottom and the whole pond or the whole ocean would freeze, and probably life as we know it would not
Mm.
exist on Earth. So that strange chemical physical quirk of water and how it's arranged in its molecules makes life possible. And maybe at the end of this series, we can talk a little bit more about that.
Mhm.
Alrighty, but now we just have to accept the fact that as we rise, the air expands and cools down, and the vapor in the water in the air condenses out as either drops or crystals of ice. But alrighty, what's this? Gotta keep track of my notes. Okay, so this is one way the clouds form. But there's another way, and I don't think we necessarily have a picture of it, but you can imagine it. Here, if the earth was totally flat, well, then we'd probably be covered all with water. But let's say the land masses were relatively flat, no mountains.
Mhm.
Okay. Then the air could just circle around and around and do what it does in its various cycles. But all of a sudden, and for us, remember we said that the most of our weather comes from the west.
Mhm.
So let's start out in California, out in San Diego or Los Angeles or San Francisco, and hear all these winds coming off the Pacific Ocean. First, they hit the coastal range, but when they hit the Rockies is also when it happens. So what happens? They can't go through. They gotta go over. And once again, as they go over, they rise up on the west side, creating clouds and rain, which is where we have our rainforests in Oregon and Washington and Northern California. And as they come back down the other side, then they dry out and we have our deserts. Same thing with the Rocky Mountains. Most of the snow falls on the western sides. By the time they get to the middle of Colorado, say the Great Plains, they're pretty dried out again. So once again, we have a very dry, central part of our country, all due to what's happening with the clouds going up and down the mountains. All right. Then what else here? Oh, I had a couple of examples. I remember once when I was driving, I used to drive west all the time to visit my kids in San Diego. And once I got over into Kansas, I'd get off on the back roads mostly. But not sometimes stayed on the interstates. It would depend on the weather. And I always got up at around 4 a.m. So I started driving pretty much in the summer, just at the beginning of light. And so there I was in northern Arizona on Interstate 40, I think. And once again, I slept over in Winslow, Arizona, high desert, fairly flat. But ahead was the 12,000-foot high mountains just on the other side of Flagstaff. And Flagstaff's at 7,000 feet. The interstate goes up, 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 up. And so as sun was coming up, there was, I forget the name of that mountain outside of Flagstaff that goes up to 12,000 feet. So you're going another mile above your 7,000. And it had a sombrero, I called it, cloud, because the cloud started about halfway up the mountain and was like a ring around, and then the peak was poking out at the top. So it looked like a hat. So once again, a sign of where your dew point happened and the clouds began to form. Alrighty. Very briefly, because when we talk about precipitation next time, I'll get into fronts more. But right now, I'll just mention, you all watch the weather on TV, I would assume. Okay, so they talk about fronts all the
Mhm.
time. Warm fronts, cold fronts, those are the two basics, and that's what we're gonna stick with. A front is simply a dividing line or separation between two huge air masses that have different temperature, humidity, and pressure. And almost always, if a high is coming in, it tends to be cooler or cold,
Mhm.
tends to be somewhat dry in humidity, and therefore dense. So it sits, it's heavy. It's
Mhm.
density and heaviness is really two different things,
Mhm.
but we tend to use them interchangeably, don't we? Alrighty, and then the warm front tends to be warmer or hotter and more humid and lighter. So, and for us at the mid latitudes, and we're around 41 degrees north, so we're about halfway from the equator to the pole. Nice place to be if you want changeable weather.
Mhm.
If you want it to be the same all the time, go down to the tropics. Anyway, and our weather tends to come from the west, maybe the northwest, southwest. And what I used to do, I listen to I don't have a TV, so my radio is important. And I used to live in Kentucky, which is a 700-mile drive west and a bit south of here. I suppose as the crow flies, probably 600 miles,
Mhm.
because roads wiggle.
Mhm.
And since air masses tend to move on the average 30 miles an hour, that would mean if the weather's coming from the southwest,
Mhm.
Louisville, Kentucky, WHAM, which AM station comes in at night. You can hear Kentucky news at night on a AM station. 20 hours before it gets here, it'll be down there. Or Chicago is also about 600 miles, pretty much straight west of here.
Mhm.
So, a little less than 20 hours. If they're having a blizzard in Chicago and the airports are shutting down, chances are in 18 hours or so, whatever they're getting, we're going to get.
Mhm.
So that's kind of a fun, if you have a radio and you can tune in those AM stations at night. Also, the fact that the winds tend to grow west to east. Have you ever flown to California? Do you remember the difference in the journey of the trip going west versus east? Okay, it always is an hour and a half longer going there because you're going against the headwinds. And that plane can step on the pedal or whatever, but still they're fighting whatever the winds are. And sometimes they can avoid it and sometimes they can't. So usually it's a longer trip going that way. It's like paddling upstream in a river. Alrighty. What else? And once again, when air masses are colliding, they're upsetting the balance. And we'll talk about that, what happens to different clouds with different weather patterns next time when we do precipitation, because otherwise we won't get done today. Alrighty, and I have to talk about lake effect snow affects weather for us because of what happened. Was it 2 weeks ago? 2 weeks ago? Alrighty. What's your name?
Suzanne.
Suzanne, have you lived in this area long, or are you originally from Buffalo or what?
No, I live in Nichols.
Oh, that's east of here.
That's right.
Yeah, they used to have a nursery for acid loving plants. Let's go. But then anyway, okay, well, how come you're here today?
I'm visiting Regina.
How are you? And where's Regina today? She always comes.
She's a volunteer at the church today.
Oh, that's right.
Sure.
I
Yeah.
forgot about that. Okay, wow. Our visitor is from east of here, about what, 100 miles?
It took me about 2 hours to get.
Yeah. Mhm. Okay, so you don't know about lake effect snow. As a matter of fact, you live in a rather magical band that runs through Binghamton. It's about 80 miles wide from the lake on down into PA, which you're sunny in the wintertime. We're not. Okay, here's what it looks. Do you know why? It is cloudy from November through March. I wonder if those solar power people know that.
I don't.
Oh, okay.
It's just the way it is.
That's why Rima decided to change her hours. Let's get stuck with my questions. Lake Erie, which pretty much lies straight west of us, and then Lake Ontario, which is to the northwest and north of us, are at about 400 feet above sea level, give or take. And in the old days, when we had colder winters, the lakes would stay open usually until November, but usually by December they were frozen over. So until they froze over and cut off that relatively warm water, I mean, you wouldn't want to go swimming in it.
Right.
But compared to what the air was doing, water, once again, one of those magical qualities is takes a lot longer to warm up and a lot longer to cool down. So and westerly or northwesterly winds coming over that 400-mile stretch of Lake Erie picked up moisture. Then it hit the shores and very rapidly within 30 miles, 20 miles, began to climb into the Allegheny Plateau, which is roughly at 2,000 feet. What happens to moist air as it goes up and cools down? Clouds. Short-term memory loss. Clouds. And then it rains or it snows. And so Buffalo in particular caught right there between Lake Erie and Lake Ontario. Doesn't matter whether the wind's coming from the west, northwest, they're right there at the apex, like the Tug Hill Plateau on the far end of Lake Ontario, towards Albany. Same thing. They might even beat out Buffalo on amount of snowfall per year. So until the lakes freeze over, there's a lot of snow dump and a lot of cloud formation. So Alfred was famous. We're really at the very edge of that, at about 90, 80 miles away. We are at the edge of that snow belt. You definitely are in a totally different situation.
We're
Where
right
you,
in between, because there's the southern part that comes up.
yeah,
And then there's that western, and we're like right
in the
between.
middle there. Oh, sunshine in the winter. Anyway, so what we were famous for, truthfully, once Halloween came and went, it would be gray, probably 5, 6 days out of 7 here, with a lot of snow in the old days, and now off again, on again, and drizzle and ice and whatever. But Buffalo, being closer, got much more. And of course, what happened 2 weeks ago, they got over 6 feet in some places. So my prediction for ski resorts, moan and groan about global warming and this crazy weather in the winters and how the ski resorts are probably going to have a hard time surviving. However, the upside is the lakes are taking much longer to freeze. And I think 2 or so years ago, Lake Erie didn't even freeze.
Right.
So as long as they're open, you're going to have these heavy snowstorms as long as the temperature is below 32 somewhere along the line. So anyway, that's what is known as lake effect. Clouds, and therefore the rain and the snow. Alrighty, let's go to our pictures. Melanie once again found all these wonderful things for me.
Which picture do you want?
Well, let's start with the Cirrus. And the contrails. Can they both be put up together or not?
Did I not get? I thought I had cirrus clouds.
Isn't that Cirrus?
Oh, those are the mare's tails?
Yes, mare's tails.
Okay.
Yep. A nickname for them.
There we go.
Aren't they beautiful? All righty. Besides the cirrus clouds, which have been around for, I don't know, 4 billion years, we have something new in the last century, the contrails. And they, in many ways, look, do we have a picture of those?
Yep.
Yeah. When they're first made by the airplanes way up high, they're very sharp. but then they
Mm.
tend to fuzz out and adapt a look very much like the cirrus clouds, because that's what they are. They're ice particles, ice crystals. Something I read in that little funny book that's here in the library, and you can test it out. Next time we have some nice cirrus clouds up there, for them and for contrails, sometimes one edge is smooth and sharp
Mhm,
and the other end's all fuzzy wuzzy.
mhm,
That shows you which way the upper atmosphere winds are blowing. I
mm,
never thought of that, but it's obvious, right?
mhm,
Let's go back to the mare's tails. Back in the day before computers, horses were very important to Western culture. And one of the reasons we know that is when I was teaching art, when we talked about color, there are probably 50, I'm going to say off the top of my head, names that indicate the
Mm.
color of a horse's coat.
mhm,
And probably 10 to 15 of them indicate some kind of brown,
mhm,
a buckskin,
mhm.
a sorrel,
Chestnut.
a what?
Chestnut.
Chestnut. Uh-huh. And so horses were everywhere in the old days. And it's obvious mare's tails blowing in the
Mhm.
wind as she runs across the pasture. Well, these are very high clouds. You maybe up to even 30,000 feet, 20,000 feet. And they are ice particles. And they indicate, we'll talk about this next time when we talk about precipitation, the beginning of a warm front moving in.
Mm,
Because once again, warm air being lighter, less dense, rises up over
Mm.
colder, dense air, and it rises up. So it gets up high, 10,
Mhm.
20, 30,000 feet. And you're going to have these kind of wispy clouds at the beginning. All right, let's move to the stratus, which have been hanging around for a couple of days. How about this one? Has that? Oh, what have you got?
I have stratus and alto stratus.
Okay, let's see the stratus first.
Oh, this might, oh yeah,
Is that fog?
I think it might be fog.
Yeah, that's fog. Which,
Don't listen to me.
okay, well, that's okay. Let's start with the fog.
Oh, you want to start?
Yeah, we'll start with the fog.
Okay.
All right. Now I had always assumed until I read that in the little book the other day, and now I forgot exactly what it said, but you can think of, okay, stratus clouds are the ones that fill up the sky, horizon to horizon. They tend to be gray, and the more likely it is to rain, the darker the gray, the thicker, more opaque they become. And once again, depending on dew point humidity, they can get pretty low.
Mhm,
If they touch the ground, then we call them fog.
mhm,
That was one definition that I had always thought of. Fog was simply very low-lying stratus clouds. Now, there's an argument about not really, because they're formed differently than this, but we won't go there yet. However, I do want to mention that there are two kinds of fog. And the first one is not usually what makes the clouds fog, but rather a radiation fog.
Mhm.
And those of you that are gardeners know in the spring and the fall, the ground cools off at night.
mhm,
And once again, as it cools off, it cools the air above it, and the moisture condenses
Mhm.
out near the ground, and you have a radiation fog. And if you're a gardener, that usually does not kill your plants
Mhm.
because it's, it's 32, 30, something
Mhm.
like that. However, when you have a large cold air mass moving into your area and it, I think I'll make sure I'm doing this right. That's not right. Forget that sentence. When a moist and usually therefore a warmer air mass moves in the summertime or in San Francisco over the bay, and it comes over cold ground. Say in the spring, you have maybe an air mass from up the Mississippi River Valley, up the Ohio, and it's warm and moist and maritime tropical
Mhm.
air mass in like March, maybe. But your ground here is still cold,
Mm.
maybe even snow on it. Then that cools everything down and causes the fog to form. That's called an advection fog, and most fogs are caused by that process. A moister, warmer air mass floating over colder. And once again, in California, it's that cold current coming down from the Arctic. And so it just chills things and they have a lot of fog out there.
Mhm.
Okay, let's see our regular stratus clouds. Now, once again, when you simplify things by models and theory, everything can be simple and clear. But when things start mixing up and combining and shifting, that's when it's like,
Mhm.
what is that cloud? I think this is fairly obvious. Stratus clouds, and I'm guessing over there to the left in the distance, it's raining already. It looks like it's raining.
Mhm.
Okay, so if that warm front is coming through to replace the cold air, first you'll get the cirrus up high, and then you'll start getting maybe altostratus, meaning halfway, and finally nimbo or nimbus stratus, the rain clouds come. And for us, usually it takes 1 or 2 days. You know, you have a beautiful blue sky for a few days,
Mhm.
and then wisps, and they get thicker,
Mhm.
and then they get more widespread, and eventually it starts really raining.
Mhm.
Okay. What else? What other kind of clouds are we looking at?
Can we get any more?
Alrighty, let's look at our storm
Cumulonimbus.
cumulus nimbus. Nimbus means rain. Ooh, isn't that a beauty? Alrighty. Once again, at the bottom of cumulus clouds are usually flat because that's the dew point line. But if we have enough energy, they keep building higher and higher and higher. Some of them go up 30, 40,000 feet, even almost to the stratus. As a matter of fact, we don't really have a good picture of it. But sometimes the top of the cloud is utterly flat. It's called an anvil, like they used to hammer on. That's where the stratosphere begins, because clouds can't go beyond the troposphere where all the weather takes place, because it's so thin beyond that point. There's just nothing there to make anything out of. But it hits that stratosphere line and flattens out, and that's the top. So these are the ones that create the thunderstorms. And in the summer, hail, which we'll talk about when we talk about precipitation. But the other neat thing about these is they go so high. If it's around sunset, my view is to the south. And every now and again down near the Pennsylvania border, there'll be a big storm going late in the day. And these things pile up. And then the sun goes down. But because of the angle, right? The tops of the clouds, just like those airplanes sometimes, are still in the sunlight. And so can be quite beautiful. Ladies, how are we doing on time?
It's 12:15. Yeah, about 15.
Oh, just 15 minutes. Oh, we're doing more than fine. We might even be done early. All righty. Now, I don't think we have any. What other pictures did we?
I have each of the fronts, a cold front and a warm front.
Okay, before we get there, well, I'll have to describe it. So there were 3 kinds of unusual clouds that I was going to mention. And we do once in a while get them here, but they're more often seen in mountainous country. Because once again, picture that air mass having to rise up over the top of the mountain and down. And sometimes that divides things up and you get what is called a lenticular cloud, like a lens. They're the ones sometimes people say, I just saw a flying saucer. That's not a flying saucer. It's a lenticular cloud, and it's sort of shaped like a lens, and usually quite white with maybe a little bit of silver gray on the bottom. And sometimes they come in a series, like there's 3 or 4 in the sky. Oh, there we go. Okay, very good, Melanie. Thank you. But after it gets past the mountain and floats down towards us.
Mhm.
See, we don't really have very high mountains to the west, so once in a while we will see them, but not very often. Okay, find a cap. This is in the chapter on, is that called cap?
Yep.
Yes. Alrighty. Once again, it's sort of like my sombrero out in Flagstaff, Arizona, except it's simply sitting on the very top of the mountain, like a cat. I didn't bring it with me, so once in a while when a volcano blows up,
Mm.
is there a picture of that? I think there is. It'll be in this same section, a weird, on top of a volcano. No, we're getting too high. Let's go back. Oh, well, maybe it's not in this book. But once in a while, when a volcano explodes and all that ash goes up 10, 20, 30, 40, 50,000 feet, even into the stratosphere, a tiny little white cloud, which has a special name, which I'm forgetting, it begins with a P, sits on top for a brief time. And finally, Virga, Virga, I think there's a picture of that in there. So, oh yeah, go to the index. I love indexes. I had a geography book once, a history geography book that was printed in 1796 in Philadelphia. No index. Who wanted to find out what the Bosnians were doing 250 years ago. Okay, well, alrighty, that's not the best, but that's a lot to do. Put it back up so they can see. This is an example of cirrus clouds way up high, and you see the rain is, or the ice crystals in this case, are beginning to fall. But as they fall, they enter warmer air and evaporate again.
Mm.
If you drive west in particular, in the deserts, in the summer monsoon seasons of July and August, you often will have a thunderstorm off in the distance, and you see the rain falling before it gets to the ground.
Mhm.
The air is still so hot and dry, it just re-evaporates. So, but Virga, I don't know if that's Spanish in origin or Latin. Alrighty. Now, let's look at our fronts, because we just have a few minutes left. And when we talk about precipitation next time, we'll
Yes, the
probably,
Warm. This is the warm front.
okay, can we make that larger?
Yeah.
Bing, 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 magic. Any larger?
It'll get a little fuzzy. That's
Okay.
probably a version.
Once again, the artist got a little carried away with more detail than we need. But let's pretend this is Alfred sitting over here on the right side and Buffalo's off to the left there, to the west. And somewhere along the line, a meteorologist, and I don't know if it was after TV with the weather report or before, they decided they would indicate the advanced line of a warm front by half circles in red. So, and it's moving in that direction. You can't really see this. Let's turn this around so you shut. So a day or two ahead of time, high up in the sky, because it's being lifted, it's lighter, the warmer air, so it's going up and over the colder air sitting on the ground. We have our cirrus clouds, and then they change into our stratus clouds, and finally it begins to rain. Or snow, depending on the temperature. If everything's below 32, from top to bottom, it will snow. Okay, what does our cold front look like? Usually this takes a day or two to happen. And when it finally starts raining, it usually rains for quite a while. Half a day, 2 days sometimes. Oh, this is much more exciting. When a cold front comes in, it happens much quicker, more quickly, which is correct. More quickly. And on the maps, they indicate it with the sharp little blue triangles. And it's once again going from left to right. Here we are sitting in Alfred with our nice warm air. And all of a sudden this cold front moves in and it creates all these cumulonimbus clouds. and you have thunderstorms. Usually in a very narrow band, it's usually over within a half hour or so. Temperature drops, which reminds me of years ago when my grandson was 6 or 7. We were driving on a hot summer day from Wellsville north to Belmont. I forget why. And it was like 85 and humid in Wellsville. We hopped in the car. I don't use air conditioning, but the car did have a thermometer, air temperature. And we could see 10, 15 miles down about 10 miles, I think, from north Wellsville to Belmont. I think it's about 10 miles up Route 19. This huge thunderstorm building up. And I said to Jordan, this was perfect. I said, it's going to be a lot colder when we get to Belmont. Why, Grandma? I said, you watch the thermometer gauge. And sure enough, every mile we went north, the temperature dropped up 1 degree. And by the time we got to Belmont, 10 miles north, it was 75 and pouring rain. So this cold front, or in this case, a thunderstorm, which sucks up all the air. You have a vacuum? No vacuums. Cold air sinks down. So when a thunderstorm passes through in the summertime, usually within a half hour, the temperature often drops 10 degrees, sometimes 15. It's wonderful when you have a hot, muggy day. So we'll talk more about this when we talk about, why it rains or why it snows or hail in the summertime. Questions? I actually got done on time. Usually I don't get done on time.
All right.
Say your name again.
I'm Suzanne.
Suzanne. Any questions?